Let's graph. Yeah. Come on. Shade it, shade it. Well, now I'm graphing it will make my grade in math soar. I'll take a test and I'm sure to get a high score. And I was thinking of ways that I could graph these lines. Today I'm gonna learn how, and I am starting right now. To know where to start, you'll need to y-intercept. Then the slope will tell you where to go on from there. If you follow these rules, then you graph it, I swear. Come on, shake, 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 shake it. 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 Now there are two types of lines, you have to know that. You can make them dashed or make them solid. And I was thinking of ways that I could tell which kind. How to determine the line. It all depends on the sign. If it's got an equal to, then you make it solid. If there's no equal to, then you make it dotted. If you follow these rules, then you can graph it. Come on, shake, 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 shake it. 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 After this graphing, there is only one thing left to find. Plug in a test, for it will tell us to shade which side. I will say either way to know which plus one is fine. 0, 0 as long as it is not on the line. It will be true or false when you plug the or in. If it comes out true, shade toward the origin. If it comes out false, shade the side opposite. Come on, shake, 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 shake it. 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 Shake, 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 shake.
Wow, what a video start there. Let's see if we can get the notes up on the board. Took a long time to find that. Probably the best review for graphing linear inequalities out there. I don't know if anybody noticed or not. There was a gigantic slide rule being played in that video. I believe the same one is somewhere up on Mrs. Lipko's wall. I might want to go check that one out. So what we have here is 1.8 graphing linear inequalities, and there's a lot of good stuff in that video we just watched. Hopefully we will be able to utilize all of that here in our notes that we're about to take. We're going to just go ahead and get started in some examples. First example we have is graphing x greater than 3. Okay, so there's not much difference between graphing lines and graphing inequalities. You basically want to start at the same place. If we're going to graph x equals 3, what would we do? Well, it's just x equals, so hopefully remember that x equals some number is a vertical line at that number. So we're just going to go to 3 and draw a vertical line. But we do have to be a little bit more careful with inequalities. First, from the video, hopefully you saw that we have greater than, less than, or we have greater than or equal to, less than or equal to. Now, the ones with the equal to are going to graph as solid lines. And the ones that are not equal to, as we have in this problem, are going to be dotted lines. So when we graph this vertical line, it's actually going to be dotted because it is just greater than 3. So we're going to put a dotted line. And now we have to decide where to shade. Now the video gave us a great idea of what we should do for shading. They said plug in the point 0, 0. Alright, well, we could do that. We have x is greater than 3. We put in the point 0, 0. Well, we'll be putting in the x value of 0. There is no y value to plug into. And we get the inequality of 0 greater than 3. Is that true? No, it is not. It is a false statement. If you get a false statement, then you will shade the side opposite of the origin. So the side opposite of the origin is going to be over here to the right. That's the side opposite of the origin. Now what's your answer? It's the whole graph. This entire graph is the solution because all points in that shaded region to the right of the dotted line, not including the dotted line, but to the right of the dotted line, all of those points are solutions. So there are infinitely many solutions to this inequality. That's why we have to use a graph to give the solution. Alright, let's graph another one. Okay, this problem we actually have x and y. So we need to get y by itself before we can decide what to do here. So we're first going to isolate the negative 2y by subtracting x and adding 5. And now we have to divide by negative 2. Hopefully you remember that when you multiply or divide by a negative, you must switch the inequality. So we get y greater than or equal to positive 1/2 x minus 5 halves. Now when we're graphing these lines or inequalities, we're going to graph them the same way we would graph any line. We start with the y-intercept. Now 5 halves is not probably the best form to graph this in, so let's go ahead and go decimal. 2.5. So we start with the y-intercept as the video suggested. Go down 1, 2, 3. So negative 2.5 is where we start. Right there. And now we're going to use the slope, okay, of 1/2 to get the second point. So we're going to go up 1 and right 2. Notice here I am using solid dots. Now the reason why I'm using solid dots is because my line's going to be solid. And the reason why the line's solid is because it is less than or equal to. Less than or equal to is a solid line, and therefore we use solid dots. If it was a dotted line, we would use open dots. So I'm going to go ahead and connect those two up. Now we have to decide, are we going to shade towards the origin or shade the opposite side? The video suggested plugging in the point 0, 0 for the origin. We plug 0 in for y. We plug 0 in for x. We end up with 0 greater than or equal to negative 2.5. Is that true? The answer is yes. 0 is greater than or equal to negative 2.5. So we're going to shade the side that has the origin on it. So all the points in that region count. Again, our solution is the entire graph. All points in the shaded region count, and the line counts. Remember, if the line is solid, the borderline also counts. Alright? Another way you can think about shading, totally up to you, plugging in the point 0, 0 is pretty easy. Another thing you can do is you can look at the when you get y by itself. So what we have here, we have y greater than or equal to So if y is greater than or equal to, you just have to remember to shade above the line. If y is less than or equal to, you would shade below the line. So greater than or greater than or equal to is above, less than or equal to is below. If you don't like that, you can always just plug in the origin. That's a really good method as well. Alright, next example. Oh, toss in an absolute value. Alright, we can handle that. We graphed absolute values before. to graph an absolute value, again, if we treat this as just a equal sign and equality, an equation, we're going to make a table. So let's first think about how we would graph the equation, y equals the absolute value of x minus 2, and then we will just shade accordingly. So, when we did this before, we first had to establish where the middle of our chart would be, or I should say the tip of the V would be when we're graphing the absolute value. And what we did to find that out was to set whatever was inside the absolute value equal to 0 and solve. So we get 2. Now 2 is where the tip of the V is going to be. So we need to pick a couple points less than 2 and a couple points greater than 2 to get the rest of the graph. So we're going to plug in 1 and 0 and 3 and 4. If you put 0 in, hopefully you can do this in your head, you get 0 minus 2, which is the absolute value of negative 2, which is 2. So the point 0, 2 will be on our graph. If we plug in 1, it will be the absolute value of negative 1, or 1. If we plug in 2, 2 minus 2 is 0. Plug in 3, 3 minus 2 is 1. And if you plug in 4, 4 minus 2 is 2. So we have to graph those points. Now we have to be very careful here. Okay, again, what kind of line are we going to get? It's just greater than. It's not equal to. Since it's not equal to, we are going to use a dotted line. And dotted lines, we must use open dots. So when I plot these, we're going to plot 0, 2 as an open dot, and 1, 1 as an open dot, 2, 0, 3, 1, and 4, 2, all as open dots connected up with a dashed line. Again, we can go right back to our 0, 0 point, so we'll plug in here. We get 0 greater than the absolute value of 0 minus 2. So is 0 greater than 2? The answer is no. So we're not going to shade the region that has the origin. We're going to shade the region that doesn't have the origin in it. And that's going to be the part which we consider the inside of the absolute value, or the V. Now if we go back to looking at y greater than or less than, y greater than would shade above. Above what? Well, it would be above the V. So go to the tip of the V and just go above it, and that's where we shade. So both cases gets us the result of an absolute value with a dotted line with infinitely many solutions in that shaded region.